Okay, so in this video, we are going to look at absolute value functions. So what we're going to look at really is how to graph in absolute value. You have a lot of experience with graphing already, so we're going to look at graphing in absolute. A lot of the same skills that you already know about graphing are going to come into effect here. Finding x and y intercepts, the vertex, domain and range are all going to come in to play here, just like they have in the past when we've graphed other types of functions. So absolute value functions, an example of an absolute value function is right here. Okay, the y equals the absolute value of x. That is an absolute value function. Its vertex is at 0 and 0, and it divides the graph in half. Okay, so why does it divide the graph in half? Well, let's look at what we would get here. Okay, so if we were to just go old school and create a table of values. Okay, let's sub in, for instance, if we subbed in a 0 for x, we know that we sub in the 0 here for the x, and we take the absolute value of 0, and we know that the absolute value of 0 is just 0. Okay, so then we go ahead and we can just plot that point on our graph. Okay, and that would be right there. If we plug in a positive 1, we will get a positive 1 because we now know the absolute value of a positive is just a positive. Okay, so that would be right there. Let's try maybe the absolute value of positive 5. Well, that would be right here. Oh, sorry, because the absolute value of 5 is 5. So we sub in a 5, we get a 5. So the point would be 5 and 5. Okay. Well, what if we subbed in the exact same numbers, but the negative of that? So what if we subbed in, for instance, negative 1? Well, you sub in your negative into the x, just like you would if you were any other function trying to create a table of values. You sub in to the x. Well, the absolute value of negative 1 we know is positive 1. So that means we're over here on the negative 1, but we're still at positive 1. What if we subbed in negative 5? Sorry. What if we subbed in negative 5? Well, if you sub in a negative 5, you get 5. So again, we go to 5, or negative 5 on the x, and we go up to 5, positive 5 on the y. So the graph of an absolute value function, this absolute value function, y equals the absolute value of x, when we go to graph that, it looks like this. So right here, 0 and 0 is the vertex of the graph. And we know vertexes from when we've dealt with quadratics. And if I had a parabola like this, we know the vertex is here. Well, that's no difference with the absolute value. It's where it changes direction. Okay, the graph is decreasing here, and then at the vertex it switches and it begins increasing. Okay, so an absolute value function is always going to look like this, because no matter what number we sub in here, it'll always come out positive. So the y value here, these y values, will never be negative. And if the y values are never negative, we never go below the x-axis. So the graph will always be above the x-axis. Okay, and that's really the main point to remember when we're dealing with absolute value functions, is that whatever you sub in for x, the y will always be positive. Alright, so with our graph, what were we saying? Well, this is basically what we were saying. Okay, for all values of x that are greater than or equal to 0, y equals x, or it's positive. If you remember back to our formal definition of an absolute value, if whatever inside the absolute value, if it's positive or 0, greater than or equal to 0, we bring it out positive. If an x value is less than 0, we have to times it by a negative to make it positive. Okay? Because it always has to be positive. Absolute value always has to be positive. So if it's greater than or equal to 0, we just pull it up. If it's less than or equal to 0, we have to times it by a negative. Okay? And that's why it comes out positive. So, since the function is defined by two different rules on two different intervals, y equals the absolute value of x is defined as a piecewise function. And we've already kind of looked at piecewise function in the first two videos. This is a piecewise function at the bottom. This is a piecewise function. And this is how you write piecewise functions. So in your assignments and the tests, when they ask you to write an absolute value function as a piecewise function, this is how you write it. Okay? You write it as y equals, and then you put this little bracket in here, x if x is greater than 0. Or it could also be negative x if x is less than 0. Because the graph is really the function is doing two different things over two different intervals. Wherever the function is positive, okay, and that's positive x there, wherever the function is positive, x is greater than 0. Okay, so wherever x is greater than 0, we just pull out whatever's inside. But wherever x is negative, we have to times it by a negative. Okay, so that's what an absolute value, or the absolute value function is. It's a piecewise function because over different intervals, it does different things. Wherever x is positive or greater than 0, it's like graphing this. Okay, but wherever x is negative, okay, we have to actually graph that, because this allows the answer, the y, to always be positive, and that's what we need. We need it to always be positive no matter what. Okay, absolute values, we learned in the first videos, are always positive. Okay, so if x, whatever is inside is greater than 0, whatever interval this is, we just pull it out. If it's going to be less than, then we need to times it by a negative. Okay, so we kind of stated this already, but here it is just in text form if you want to copy it in your notes. Because the absolute value cannot be negative, the graph will never cross the x-axis. Okay? Because that means if the absolute value of x is always positive, that means y can never be negative. And if y is never negative, we can't cross the x-axis, because below the x-axis is where y is negative. So we'll never cross the x-axis when we are graphing absolute value functions. Okay? Y equals the absolute value of x is related to y equals x. Okay? And I'll just draw a little graph here in the corner to kind of show why. If that's our Cartesian plane, if I was to graph y equals x, it would just look like this. Whatever value I sub in for x, I'll get the same value for y. Okay, so if I sub in a -1, I'll get a -1, -2, -2, -3, -3. Okay, +1, +1, +2, +2, etc. Okay, So they're related in the fact that the part below the x-axis in y equals x is reflected in the x-axis. Okay, so the part above the x-axis is the same. So the graph of the absolute value of x, or y equals the absolute value of x, okay, is going to look similar to this, except for the fact that this part down here will be reflected in the x-axis and be there. So if I'm going to, let me just label this here, okay, this was y equals x, and the graph of the absolute value of x will be the same except it's then reflected. So this is y equals the absolute value of x, okay, where the black part down here is still y equals x. Okay, so this part's the same for both of these. This part is the same, but this part down here is reflected in the x-axis and becomes here. Okay, so where down here we would have had -1 and -1, we now have -1 and 1, because when we sub -1 into here, we'll get a +1 back. But when we sub -1 into here, we just get -1. Okay, so it just shows the relationship between the two. You'll be asked on the test, in the assignments, you'll be given a graph of something like this where it doesn't have the absolute value in it, and they'll be asked, what would the graph of this look like if you're already given this? Okay, so that's something that you'll need to know throughout the assignments and for your test. All right, folks, let's look at some examples now.